Whoa. All right, as you might have noticed, I'm having some technical difficulties here. You may have seen my cat there on screen for a second. This is Dr. B. Welcome to my stream. I'm also having some audio issues. It sounds like I'm kind of in a very big room. I'm not. I'm in kind of a small room. But tonight we are going to look at electron configurations by popular demand, because this is such an essential topic in chemistry. If you master these electron configurations, it makes a lot of chemistry much easier. So remind me at the end, and I'll put the PDF guide on electron configurations in the chat for you. You can download that directly. So let's jump over here to my screen. Right here. There we go. So we're going to work through problems for about 20 minutes here and see what we can do to figure out these electron configurations. So first question, see if you can do this. We want to know, and this is a general chemistry question. You'll see these on most exams, something like this. How many electrons are in the sulfur atom? Atomic number 16. Put this over here. You might remember this from before. So here's atomic number 16. The atomic number equals the number of protons, but since all of the elements on the periodic table, they're neutral, protons equal electrons. So 16, sulfur, it has 16 protons, but it also has 16 electrons. And that's really key information. So if you looked at a sulfur atom right here, you can see that we have 16 if you count all of these up, and they're arranged in energy levels. First energy level, second energy level, third energy level. And from that, we can figure out the electron configuration. So let's try something over here. Give this a try, and I'm going to put I'm going to take and put a poll in the chat. So you can go right to the chat and do the problem because the question's there and everything. Let me try that. This is the first time I've actually tried this, so this is a good test. Scientists are always experimenting. Give it a try, and then I'll pull up the results as we do this. I can see there's about 12 people here right now, so maybe we'll have a few people do this. And besides, I do teach some organic chemistry. I like organic chemistry, but not at a super high level. Let's go back to me so I can work on my screen here a second. So I'm not seeing any responses yet. So far, my experiment is not going well. There's also a delay here. When I speak, it's about 15 seconds until it actually gets up to YouTube and down to you. So there's a pretty good delay. And that's kind of a weird thing as a teacher. I'm not used to that. All right, there's a response. Okay. Oh, so that person got it right. Wait another second for this, and we'll come back to this in a bit. So at least we see that the form does work, and that's what I really wanted to test here. We'll go back and look at that in just a bit. Let's move on along because I want to make sure you get all of this stuff here. So if we've got atomic number 36 here, we just look at 36. That's krypton, 36 protons, 36 electrons. Not too bad, right? So we're going to get over to something a little bit more challenging here. Now, I'd like you to write the electron configuration for sulfur and identify its valence electrons. This will be on a test. You'll see questions like this quite often. So take a look at it. Just think about that. How do we do that? So here's sulfur, 16 total electrons, and we want to arrange them around the nucleus. So the way we do this, we look at the periodic table. We start out with 1s, that's 1s1, 1s2. The first energy level here, it's full, so we have to go to 2s. This is the second energy level, 2s1, 2s2. We go to the third, we're in the second energy level still, so we have 2p, 1, 2, 3, 4, 5, 6. But that's full. We've used 10. Remember, we have 16. So we go to the third energy level, 3s1, 3s2. And we then go to 3p, 1, 2, 3, 4. 3p4, that's sulfur. If you count all of these numbers up, you'll get 16, just like the atomic number. But what about the valence electrons, the ones on the outside? Just look at the highest energy level. 3 is the highest coefficient here. Sulfur has 2 plus 4, 6 valence electrons. So you can figure that out right from the electron configuration. And if you look at it, if you look at sulfur here, here's the first energy level right here. And there are just 2 in the first energy level. That's 1s2. Second energy level, the s, we have 2 of the s's, 6 of the p's. 2s2, 2p6. Outer energy level, the valence electrons, we have 2 of the s's right here, and 1, 2, 3, 4. You see those last 2 spread out. I hope that makes sense, because you're going to hopefully try another poll here. Sometimes you'll see this diagram here in chemistry class, and the idea is you go like this, 1s2, 2s2, 2p2, 2p6, 3s2. You follow the arrows. I really don't like this because it's kind of detached from how the periodic table is built. So if your teacher gives you this, it's okay, but it's much better to remember these blocks here and do it that way. Do some practice with that. All right. So I'd like you guys to give this one a try, and I'm going to try the poll thing again. How did we do with that here? How many do we have? 3 responses. It kind of updates them in real time. That's pretty cool. And it shows how many people got right. One person got confused, probably because they thought K was potassium, and that would be 19, but Kr for krypton. Pretty cool. All right. So I think I have that on my clipboard. Give that a try. See if we can get more than 3 people doing this. Go back to me for a second here, and I will see if I can get the responses. There we go. All right, we're waiting for responses. There are 14 people here, so hopefully 14 people have gone to chat and are giving this a try. All right, we got one person got it right so far. Very cool. And reload that. I think it does it automatically. It's pretty cool. All right, I'm going to let that go for just another few seconds since this is a longer problem. 2 responses. Both of them right. Wow, you guys are good. Everybody's getting it right. 3 responses. Sweet. I'm going to jump over here and go back to our... Look at this here. And so a Bohr diagram, right here, the Bohr diagram, that's when you see the nucleus here, and then they just have these shells or energy levels, and first, second, third. So I can just look at this and see that the first energy level, I have 1, that's the first energy level, and 2 in there, S2. S's only hold 2. Second energy level, I've got these 2 here, those are the S's. So second energy level, S2, and then 2, 4, 6. So 2p6, and then those valence electrons, 3s2, and then 2, 4, 6, 3p6, and 2 plus 2 plus 6 is 10, 18. That's argon. So all the folks that put argon, they got it right. And the valence electrons here, again, it's that highest number, which is 3. So all of these here have 8. They're noble gases. This is a full outer shell. So it's all set up. It's all full, and they are not reactive. The only exception to this is helium, because helium only has 2 valence electrons, or 2 electrons. So helium would just be 1s2. That energy level is full. That's why we call helium a noble gas. It's got a full energy level. All right. So when you're doing these electron configurations, the way to really do this is practice them. Just keep practicing them and practicing them in different ways. You want to relate it to the atom. How are the electrons arranged around the atom? Because that's really what we're doing. And then once you know the valence electrons, you can start to look at chemical reactivity. Like these aren't reactive because the outer shell or the highest energy level is full. So we can tie all these things together like that. Go back to our poll here, and we have 5 responses there, and everybody got it right. So either you're real smart or I'm doing a good job. I'm not sure which. And I agree, Muna, it's hard and easy at the same time. That is very true. That's true for chemistry in general, I think. All right, let's go back here. We're going to do 1 or 2 more. This is an AP chemistry type question here. Write the complete electron configuration for krypton. And they want you to talk about energy levels in subshells. But that's just that 1s2, 2s2 stuff. So if you're doing that, you are writing the energy levels in subshells, and you will follow Hund's rule in the Pauli exclusion principle. So give it a try. Krypton. Take about a minute. It's a little bit further. And you need to know how many. Krypton's right here. Atomic number 36. Follow the numbers across until you get to 36, and you get to krypton right there. So let's look at krypton. We have 36 total valence electrons, and all 36 of those, we need to organize them around the nucleus. But you can do this thing that's kind of cool. You can look and see you have first energy level, second energy level, third, and fourth. So krypton's in the fourth energy level. It's going to end 4 something. And we can see that it's going to be P 1, 2, 3, 4, 5, 6. So we know that krypton, the last thing, is going to be 4p6 before we even start. So let's go ahead and do it. 1s1, 1s2, 2s2, 2p6. P can only hold up to 6. 3s2, 3p. I'm going to have to move this here. Oh, that always happens. Let's move it over here. So 3s2, 3p6. Then we go to the fourth energy level because the p's are all full. 4s2. And then you get 4p6. So that is the electron configuration for krypton right there. And it's really cool because you can look at this. If you remember, all these end in S1, S2. You have the D block and then the p's here. You can find the last term almost instantly. If we look at krypton, it is helpful. Again, you can kind of imagine that we have our 1s2 here and our 2s2, and then we start getting our p's that we fill out from that nucleus. And that has to do with Hund's rule. We fill the lowest energies first, and then Pauli says that we always have pairs and they're spinning in opposite directions. That's kind of a real general interpretation. But if you can do this, you guys are doing great. We're going to do one more. You guys feel like doing one more here? We've been going for about 15 minutes or so. That's about all you really want to study without a break. We'll do one more. All right. Let's skip that one. Let's do this one right here. I just want to show you this before we wrap up. So again, what we're doing, we're building out the pattern of the electrons from the nucleus. But check this out. This is chlorine. It ends with 3s2, 3p5. It almost has 8 valence electrons. If we had one more electron, we put it right here, that would make this 3p6, and that would be very stable like a noble gas. But when we do that, we've added an extra electron. So this is Cl minus, the chloride ion. So it becomes a negative ion because we added the extra electron. So in nature, chlorine will always be 1 minus because it gets one more electron. Its ionic charge is 1 minus, and when it forms chemical bonds, it'll try to get that extra electron. Sodium ends in 3s1. It only has this 1 valence electron. So it'll lose that. It won't try to gain 7 to get 8. Sometimes it'll lose it to chlorine, like in NaCl. When it loses that, it loses this here. Underneath it, it has right here 2s2, 2p6, 8 electrons. We get rid of this because it lost it. There are those 8 valence electrons. Very, very stable. So that's a real important concept. And because it lost an electron, now it's Na+. So we can use these to figure ions out as well. So let me do this then. Let's go ahead and I'm going to get the link for that PDF I told you about and see if I can find that here. And it's on breslin.org. That's my website. Here it is. So this is the first draft. If you see anything wrong with it, let me know and I'll fix it. But it's really kind of useful in that. Let's go back to my screen here. it has the information that you need, but it has links to all my videos. It explains how to do configurations. It has this diagram and this one, and then lots of practice, and all the practice goes to my videos. It has the answers in it as well. So really useful. Hopefully that's something that will help you succeed in chemistry. So that's really all I got for you tonight. I got to figure this sound problem out somewhere here, and so I don't sound all echoey, like I got some digital delay going on. I'm going to wrap up, but I'll stay on for a few minutes here in the chat. Thank you, everybody. This is Dr. B, and I'll be back on this Tuesday and Thursday. I'm going to try to stream Sundays, Tuesdays, and Thursdays. Thanks for watching.